Cambridge AS Computer Science, Chapter 3, Hardware, Logic Gates and Logic Circuits. We have to study logic gates. There are 6 logic gates. What I am saying right now is exactly the same as in the computer science O level. Nothing new. Maybe questions are a little bit more complicated. However, basics are just the same. So, logic gates accept ones and zeros and output ones and zeros. Logic gates only receive inputs as ones and zeros and produce outputs as ones and zeros. Okay? The simplest is the NOT gate. The simplest is the NOT gate. And you have to learn how to draw it. Okay? The NOT gate is a triangle like this, and this is supposed to be the input. That circle represent the NOT function. What is that NOT function? If 0 is input, the output will be 1. If 1 is input, the output will be 0. It is just the opposite. Little bit similar to the negative sign in mathematics. Okay? Then we have what we may call the truth table. This is called the truth table. And it only has one input, A. So the input is A. If the input A is 0, then the output X is 1. If input A is 1, the output X is 0. This is the only gate that receives only one input. Okay? So this is the NOT gate. Next is the AND gate. You have to learn how to draw it. A straight line from here and half a circle. And these are the two inputs, and this is the single output. All the logic gates we are studying, they produce just one output. Okay? Okay. And it is written as AND. This is the AND gate. Okay? And this is the truth table. The AND gate is little bit strict. Okay? Okay. So it has two inputs. It has two inputs. And the only time it produces one is that one both is when both inputs are one. So inputs will be in the following pattern: 0, 0, 0, 1, 1, 0, 1, 1. These are all possible combinations of ones and zeros for two inputs. Okay? Okay, that AND gate operates as follows. If 0 and 0 are input, this is A and this is B. So A is 0 and B is 0, the output X is 0. 0 and 1, also the output X is 0. 1 and 0, also the output X is 0. 1 and 1, so it is very strict. Its only way to output 1 in the output is that both inputs are 1. So this is the AND gate. Okay? Next is the OR gate. The OR gate is very little bit lenient or kind. Okay? It looks the same. It looks pretty much the same. However, the straight line here is not a straight line. It is a curve. And the half circle here has whatever you can say. It looks like this. You have to practice drawing. You have to practice drawing. Okay? The OR gate is very kind. The OR gate is very kind because any sort of input equals to 1 will produce an output equals to 1. The only case, the only time it outputs 0 is when both inputs are 0. Okay? So 0 and 0 will output 0. 0 and 1, it's okay. OR is like the union. So the union of that and that. 0 and 1 union produces 1. 1 and 0 union produces 1. 1 and 1 union produces 1. The AND is somehow like intersection. The intersection between one here and one here produces one here. Okay? Okay. Then if you have studied the not and or, then the coming three can be explained using the upper three. Because this is the NAND. This is the NAND. We call it not and. We call it not and because it looks like the AND gate with a circle after it. Looks like an AND gate with a circle after, and that circle is the circle of the not. So it is not and. So if the AND, the output of the AND is 0, 0, 0, 1, the output of the NAND is just the opposite, 1, 1, 1, 0. So at the beginning, if you are unable to study all of them, just study and or not, and then think that the NAND is the opposite of the AND. So the AND output 0, 0, 0, 1, the NAND output 1, 1, 1, 0. And think of it as if it functions like the AND and then reverse the output. So the NAND is the reverse of the AND. Similarly, that is called NOR. It's an OR gate followed by a NOT. That's why we call it not OR. So it's a NOR. And if the output of the OR is 0, 1, 1, 1, the output here is 1, 0, 0, 0. It is just the opposite of the OR gate. Okay? The last thing to explain is called the XOR or the XOR or exclusive OR. Okay? It is somehow derived from here. It is somehow derived from the OR gate because the output of the OR gate is 0, 1, 1, 1. Here the output is 0, 1, 1, and 0 again. Looks like we are excluding the 1, 1, similar to the OR. With the OR, the 1, 1 outputs 1. Here we exclude this and the 1, 1 outputs a 0. We can study it in another way. We can study this, the XOR, in another way. Definitely, you need to memorize this. This looks like your new multiplication table to be able to go through questions like this. Okay? So the XOR, let us explain the XOR in another way. Okay? If the two inputs are the same, 0 and 0, or the two inputs are the same, 1 and 1, it outputs a 0. If the two inputs are different, 0 and 1, or 1 on 0, it outputs a 1. Okay, study it the way you wish, but you need to learn all these very, very well. We call this the truth table. This is the truth table. The input is always 0, 0, 0, 1, 1, 0, 1, 1 in that order. For one reason, because if you convert these into denary, 0, 0 will convert into 1. 0, 1, and I'm sorry, 0, 0 will convert into 0. 0, 1 will convert into 1. 1, 0 will convert into 2, and 1, 1 will convert into 3. So that order is meant. That order is in ascending order of value. Okay? So please study, just study it very, very well. Okay? The AND gate, 0, 0, 0, 1. The only time the AND gate produces 1 is when both inputs are 1. Okay? That sort of puzzles used to come frequent, often in the O-level. The OR gate is very kind. The only time it produces 0 is when both inputs are 0. The NAND gate is the opposite of the AND. So in the NAND gate, the only time it produces 0 is when both inputs are 1, just opposite to this. Here, the only time it produces 1 in the NOR gate is when both inputs are 0. Here, if both inputs are the same, 0, 0 and 1, 1, it produces 0. If inputs are different, 0 and 1 and 1 and 0, then it produces 1. Okay, this is just copied from your classified. Look at this. This is just copied from your classified. Oh, AS21 June paper 1-1. It says output is 1 only when both inputs are 1. This is in the NAND. The output is 1 only when both inputs are 1. This is in the NAND. Okay? The output is 1 only when both inputs are different. Yeah, this is the XOR, the XOR. The output is 1 only when both inputs are 0. This is the NOR because it's the opposite of the OR. Okay? So puzzles like this should, out of your understanding of these. Okay? Okay? Well, I have loads of questions like this in the O level, but we are doing now AS. Okay? Let me give you questions go directly into more in detail, more in-depth questions. Okay? Okay, that is enough. Just take this and study these. And I recommend so much, if you haven't studied O level, just listen to O level lessons. We explain it thoroughly there. Okay? I will stop here because other things, they need plenty of time. For example, I would like the output X in terms of inputs A, B, C. So inputs A, B, C will take that form, and this will be given in the question. However, I would like to find the column for X. I cannot do this directly. I have to go through stages. So I will find the output at column D. I will find the output at B. Okay? Okay. That's it for now. Thank you so much.